Okay, all right. So today we are going to begin this session number 8, and in this session we are going to solve problems based on the economic aspects for power distribution planning. So let's start with the first problem. So the first problem is that a substation expansion needs 50 lakh rupees after 5 years of now. How much money the utility should have right now to do the expansion? Assume discount factor as 10% and the options are given below. So what you can do, you can solve parallelly with me and whatever answer you got, you can type your answer in the chat box. So let us see what are the given things here. Given are this so this is future worth 50 lakh rupees after 5 years, so it is future worth rupee 50 lakh, and this 5 years is number of years or future years, you can take it as t is equal to 5, and how much money the utility should have right now. So we have to find out the present worth to do the expansion and assume discount factor as 10%. So discount rate is given, D is given as 10%. So we know that the present worth factor the present worth factor is related to the discount rate, as discount rate we have denoted it by D as 1 divided by 1 plus D power T. So it is, if we see in this question, so we can say that present worth factor is 1 plus 0.1 power T. T is given as 5. So it will come as 0.621. And we also know that value today of X rupees T years ahead. Means suppose X rupees T years ahead, what amount equivalent value at present. So it will be equal to X into present worth factor. So directly you can write X is given as rupee 50 lakh and present worth factor is 0.621. So you will get Value is 31 lakh 4606. So which is the correct answer? So the correct answer is C. Yes, Manish is correct. And you all please try the problems whatever we are solving. So it is the future worth. And if you see the from the options, you can directly also tell without solving, because whatever the money right now we need, it should always less than the amount that we need in future. So all the options, only two options can be feasible, B and C. And for and find and after doing calculation, you can surely say that C is the correct option. A is same as the future worth and D is more than. D cannot be possible. So C is the correct answer only. So just similar to this problem, we will solve problem number two. And if you feel any problem, any doubt, then you can ask me in between. The second problem is that a utility needs 30 lakh right now to do expansion of a substation. A utility company needs 30 lakh right now to do expansion of a substation. How much that is, this is present worth, present value of money. How much money will be needed 4 years later? So to do the same expansion, assume discount factor as 10%. So we have to find out the future value of money after 4 years. So let us just write what are the data we have given. So present worth rupees 30 lakh. Future future year or number of years, you can say. It's better to say number of years. Number of years. T is given as 4. And then we have discount rate. Discount rate. D is given as 0.1. So how we can find out present worth factor? PWF. So 1 plus 1 divided by 1 plus D power T. So 1 power 1, 4. It will be 0.683. Therefore, we know that value today of X rupees T years ahead X rupees T years ahead is equal to X into present worth factor as we write in the previous slide. So, so here this present value is given this much rupee 30 lakh, and we have to find the future worth. X multiplied with 0.683. X is what? Future worth. Future value of money. So it will be 30,000 divided by 0.683. So it will be 43 lakhs 92,300 is the final answer. 43 lakh 92,300. C is the correct option. Yes, Manish, you are correct. Nitish, yes, Nitish has given correct answer. C is the correct answer. 43 lakh 92,300. Similar to the same concept, we will solve the next problem. So the next problem is that I don't know. Today everyone is joining late. So third problem is that if a substation requires 40 lakh 6 years from now, what is the discount rate if the present worth of this money is 30 lakh? So what are the data we have given? We have given future worth 40 lakhs, future value of money is rupees 40 lakh, and this number of years is given as 6. What the we need to find out this discount rate. D is equal to what? If the present worth of this money is 30 lakh, present value of money is given as 30 lakh. So we know that value today of value today of x rupees t years ahead, x t years ahead is x into present worth factor. So we having future worth, present worth is given as 30 lakhs, and this future worth is given as 40 lakhs, x value is given as 40 lakhs, and then we having, we know that present worth factor is 1 plus 1 divided by 1 plus d power t. So t value is 6. So from here you will get 1 plus d power 6 is equal to 4 by 3. Therefore you will get d value as 4 divided by 3, 1 divided by 6 minus 1. So I will get 0.049 or 4.9%. So among the options, A is the correct answer. So 4.9% is the correct choice. So C is now not the correct answer. A is the correct option. 4.9. So remember this term means whatever the amount in the future be required for the expansion, that will differs from the whatever the amount we needed in the present. So okay, if you feel any doubt, then you can ask me. Otherwise, we can move to the next problem. So the next problem is that it is based on the levelized cost for the planning. So the question is the present worth of a distribution network planning is 10 lakhs for a planning period of 5 years. What will be the levelized cost for this planning? Assume discount factor as 10%. Levelized, we need to find this levelized cost. So here we having given as this present value of money and the number of years planning period, that is planning period, and discount rate we have given. So given values are present worth, present value of money is rupees 10 lakhs, and this number of years T is given as 5, and we have given discount rate. Discount rate is 0.1 or 10%. So we know that levelized value of Q over n years, it's better to say T years, over T years is Q into D into 1 plus D power T divided by 1 plus D power T minus 1. So all of you please remember this expression. This is very important. So we will put all these values. So this is Q, present value of money. So rupees 10 lakh will be multiplied with this expression 0.1 into 1.1 power T is 5, and then denominator is 1 power 1, 5 minus 1. Then we will get rupees 10 lakh into 0.2637 797. Upon multiplying this, you will get the levelized value of money as 2,63,797. So correct option is B. How many of you are able to get this answer? No one is trying. So these problems are based on the expression. If you know this expression, then you can getly solve. You are able to solve the problem. These two expressions are very important. Levelized value of money and the how you relate with present worth and future worth using this present worth factor. So now these four questions are based numerical based problems. Now we will solve theoretical problems. So question 5 is that the present worth factor needs to be multiplied with, and the options are future non-recurring cost, B option is future recurring cost, and C option is both future non-recurring and recurring costs, and D option is neither future non-recurring cost nor recurring cost. So what is the correct option? You type your answer in the chat box. Is B. No, B is not correct option answer. So if you define the recurring cost and non-recurring costs, so recurring cost refers to the expenses that is known, anticipated, or occurs at regular intervals, and the non-recurring cost that occurs at irregular intervals, that is not predictable and is not generally anticipated. And the examples of these recurring costs are like that the cost we will provide electricity will be given to the production utility, or the periodic utility expenses, routine sales and marketing expenses, and depreciation expenses are some of the recurring cost example. And if we see the non-recurring cost examples like restructuring cost, replacing equipment, emergency maintenance expense, expansion costs, losses due to natural disaster, and other unforeseen expenses. So this formula for this future worth and present worth, whatever we are using, this both costs are added up. So we need to multiply it with both future non-recurring and recurring costs. So C is the correct answer. So the present worth factor needs to be multiplied with the both future non-recurring and recurring cost to get the present values. So C is the correct answer. Let us see the next problem. This is very simple one. The static planning of power distribution system is, and the options are one step planning without consideration of load growth. B option is multi-step planning with consideration of load growth. C is contingency planning. D is all of these. So you type your answer in the chat box. Jignesh Nitish. Jignesh has given A option. This D. Yes, A is correct option. So if we broadly categorize this distribution system planning, so we know that these are divided in two types, a static planning and dynamic planning. A static planning is that in which we consider the load growth. Load growth is considered, while dynamic planning is that in which, sorry, it is incorrect. Load growth is not considered. I don't know what is. While dynamic planning is that load growth is considered, and it is again classified in two types. Um, Suppose if we having load growth in the existing network, and next is the addition of new nodes, that is expansion planning. So here it is asked about the static planning. So it is one step planning without consideration of load growth. A is the correct option. So static planning is that in which load growth is not considered, while dynamic planning is that in which load growth is considered. So let us move to the next problem. Next problem is that dynamic planning of power distribution systems is. It is similar to the previous problem, and here again this. So just similar to the previous problem. So this one is the multi-step planning with consideration of load growth. So B is the correct option for say, this dynamic planning. Yes, B is the correct option. Jignesh Pujara. Now let us see the next problem. So the next problem is that the meta-heuristic optimization algorithm works with, and the options are these. First, I let you know that this is multiple select question. Multiple options can be correct. So this question 8 is multiple select question. Multiple options can be correct. So whatever answer you feel that is correct, you can type your answer in chat box. So Nitish has given A and B. Other one, please try. Options are calculus based mathematical rules. B option is nature inspired meta heuristic rules. C option is iterative updating of randomly generated solutions. And D option is non iterative direct solution approach. So if you gone through the slides of video lectures, then you can easily predict that this calculus based mathematical rules comes under the deterministic algorithms or mathematical logic based algorithms, and this nature inspired meta heuristic rules comes under this optimization algorithm. So B is the correct option. This is not correct, and iterative updating of randomly generated solution is also correct choice, and this non-iterative direct solution approach is also incorrect option. So the finally we having correct options are B and C. Yes, Jignesh, B and C is the correct option. So next, let us see the next problem. The next problem is that the advantages of meta-heuristic optimization algorithms are. So these can be used in solving non-linear problems. B option is these can be used in solving problems with non-differentiable objective functions. C option is that these can be used in solving problems with large number of variables. And D option is all of these. So what do you think? What should be the option correct choice for this meta-heuristics optimization algorithms? Yes, Nitish and Jignesh, both you, both of you are correct. D is the correct answer. That's why these meta-heuristic optimization algorithms are widely used and commonly used in the optimization problems because of these advantages. So all of these is the correct option. So yes, the meta-heuristic optimization algorithm is used in solving nonlinear problems, and it is used in solving problems with non-differentiable objective function along with differentiable objective function, and this is also used in solving problems with large number of variables. So let us see the next problem. So the next problem is that it is just opposite of these advantages. So here in this question it is asked about the limitations. The limitations of meta-heuristic optimization algorithms are. It is also multiple select question in which multiple options can be correct. Multiple select question. So the limitation of meta-heuristic optimization algorithms are options are they cannot always provide global optimal solution. B option is they sometimes provide only local optimal solutions. C option is that the execution time is very long, and D option is all of these. A and B. Jignesh, A and C. So Nitish, you are correct. So they cannot always provide global optimal solution. They sometimes provide only local optimal solutions. So both are the limitations for the meta-heuristic optimization algorithms. So A and B are the correct choices. And sometimes it also run in a single run. So this is incorrect. This cannot be the this is not true. The execution time is it's fast in this meta-heuristic optimization algorithms. So it is not long. So this is the incorrect choice. So A and B are the correct options for this question number 10. So now let us see the next problem. So the next problem is that which of the following decision variables of a distribution system planning problem is integer in nature? So the decision variables of distribution system planning problem is integer in nature, and the options are determination of optimal substation size, determination of optimal feeder routes, and the determination of optimal line conductor sizes. And the option is all of these. So here in this question, it is asked about the variables, and it is asked that in which flowing decision variables these are the integer in nature. So D Jignesh and Nitish is saying C. So Jignesh is right. D is the correct option. All of these, so all these decision variables are integer in nature. So D is the correct choice. And the next problem we having, this is the last problem for this session. So the next problem is that which one of the following is not a meta-heuristic optimization approach? And the options are genetic algorithm, particle swarm optimization, dynamic programming, all of these. So you type your answer in the chat box. So Nitish, Jignesh, yes, Jignesh, Nitish, both of you are saying C. Yes, C is the correct option. Dynamic programming. Dynamic programming comes under this mathematical logic-based algorithms. So if you uh, just differentiate these solution strategies, then we are having mathematical logic-based algorithms and these meta-heuristic algorithms. These are the solution strategies for this optimization problem. And in mathematical logic-based algorithms, the flowings comes under this category: branch mixed integer programming, branch and bound, Bender's decomposition, dynamic programming, and nonlinear programming. So dynamic programming, this does not comes in meta-heuristic algorithm. So this is the correct option C. And if we see in this meta-heuristic algorithms, the some of are the like expert systems, branch exchange, network flow programming, simulated annealing, and the population-based meta-heuristic algorithms are genetic algorithm, that is one of the widely used, and colony optimization, this artificial immune system, and particle swarm optimization, which we uh, which one particle swarm optimization is also one of the most widely used technique, widely used solution strategy for the optimization problem. So that is all for today's session. If you having any doubt, then you can ask me. I think today's session little bit short because most of the problems are theoretical. In this session, we are having less numerical type problems, so we can we are able to solve problems very fast.
Hello.
Yes.
Uh, uh, I have query regarding the last assignment.
Okay. Tell me.
Assignment 8. Actually, I have raised in
So
forum.
the present one or the that we have discussed in the session.
No, no, but the solved whatever solved assignment number 8 is there. It is actually is already given, and which answer is also we can see, right?
Okay. Okay. Yeah.
So I have raised one query also
Yes.
for that. Question number 6 is which of the following consume leading reactive power?
Yeah.
So in that the right options that is mentioned
Yes.
is overexcited synchronous generator and capacitor.
Yes. Yes.
But according to one leading book, Prabha Kundur,
Yes.
it is recognized, I think, by IEEE also. It is a very good book. In that also there is a written that transformer is consuming the leading reactive power. All other things, that is overexcited synchronous generator and capacitor, which are giving leading or supplying the leading reactive power. So I have one screenshot also of that book. Actually, the marks is not important, but concept-wise, I want that it is the right
Yeah.
thing.
So the response we have given, and the capacitor always what? This consume leading reactive power and supplies lagging reactive power.
Yes,
That's why it compensates the reactive power, and we are able to improve the power factors.
yes, yes.
And so it is not like that this capacitor will will consume lagging reactive power.
Hmm. So capacitor is supplying actually leading reactive power.
Capacitor supplying, you're saying correct.
But
Is capacitor is supplying is supplying
no,
sorry, capacitor is supplying leading
leading.
lagging reactive power, not leading reactive power. Capacitor is consuming leading reactive power.
Mhm.
So it is little bit just
Because the capacitor is always giving leading power factor. Okay, so
uh,
it having leading reactive power. And in that book also, if you can see that in that book also, there is written that
hello. I think he disconnected. So I think he's a little bit have to see more clearly. It's little bit confusing, but if you go through this, whatever we have responded, that is correct. I don't know how he disconnected. Yes. Hello. Yes, Jignesh.
yes, 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 yes.
Yeah.
So transformer always absorbs the leading reactive power.
Transformer. It's yes. Acts like an inductor. So
Yes. See,
it will.
always absorbs or consume reactive power, regardless of their loading.
And so if you incorporate lagging leading, then you have to tell in the terms of consume and supply. So if
Okay,
you are incorporating lagging, means it's like it is consuming lagging reactive power transformer.
okay. It consumes, na?
Yeah.
But it is also right answer. Transformer is consuming that the leading power factor,
No, no.
leading
How?
reactive power.
Uh, that's why it is incorrect, because in
Okay, lagging. It means it should be lagging.
uh,
It consumes lagging reactive power.
then it is correct transformer.
Okay, okay, okay,
It just a little bit if you go through yourself, then it will clear.
okay, okay.
Otherwise you can write in that had we replied, we will try to include more things in that, because it is a really good concept, lagging, leading, reactive power, all these things.
Right, but whatever that is with reference to the power factor also. So in power factor, they are just reverse, I think, because capacitor is supplying, it is not consuming the leaking. It
Capacitor,
gives the
capacitor is supplying what? Lagging or leading? That is the question.
capacitor supplying leading power factor. Over excited synchronous generator is also
No, no,
supplying
capacitor
leading,
is supplying lagging reactive power,
leading, leading.
and capacitor is supplying lagging reactive power means just analogous that it will consume leading reactive power. Means
But what is the
you,
meaning of that lagging reactive power? And at the time of leading reactive power, what will be the power factor?
at
And
that
how we can say about any reactive power is leading or lagging, right? With reference to only the phase angle, okay?
so you have to see the means amount of reactive power. If it is comes if it is come positive for a load, then it is consuming lagging reactive power. And
Hmm.
suppose if it is if
Hmm,
comes as a
hmm.
negative, then it will supply lagging reactive power.
Okay. Is supplying, then it is lagging.
If reactive powers you have calculated for a load,
Okay.
suppose if a reactive power calculated load, it comes out as negative,
Okay.
that it means it is supplying lagging reactive power and it is consuming leading reactive power.
Okay. Okay.
So consumes means if it, anything's just like that, if it is if it is consuming lagging reactive power, then it becomes supplying leading reactive power. This is
Okay.
clear or not?
Okay. Okay. That is clear. But
Huh.
there is no relationship between any power factor or phase angle with reference to the reactive power then.
What is power factor or phase angle?
Yes. Because what we say that you have said that is supplying or consuming with reference to that only,
Yeah.
right? So capacitor is supplying, I think it is supplying leading, supplying reactive power, not
S-
leading or lagging, we say that, but
Supplying reactive power, sometimes
capacitor.
it is generalized form, but you have to if you have to just remember that is supplying lagging reactive power and it is consuming leading reactive power.
Okay. But, that supplying leading reactive power. Okay.
So, no, no, supplying
Supply,
la-
supplying lagging.
lagging reactive power.
Hmm. Hmm.
So I think you can
Lagging.
ask their.
Okay. Okay, I will ask, but uh, lagging and leading we term is used generally with reference to power factor. Okay.
Yeah.
Okay. So capacitor is giving leading power factor always. If we consider,
Yes,
uh, uh,
current is leading in nature.
so power factor is always leading.
Power factor is leading. Yes.
Okay. So, with reference to which we can say that it is a leading or in terms of reactive power, it is leading or lagging. In power factor, we know that capacitor always having leading power factor and inductor having lagging power factor. So, it is just opposite that of nature, what we say in reactive power. So, uh,
So here terms comes that consume or supply. That you have to remember.
uh, uh,
Here terms
okay,
consume supply. That is
okay,
the main thing.
okay. Supply and okay, supply or consume, that is the right thing.
Yeah.
But hmm,
It,
but it depends on
so
uh,
means you generally think that whatever the loads we are having, lagging, we are
hmm,
having inductive type of loads,
yes, yes, yes,
and so that
yes.
will demand lagging reactive power. So
Okay.
who will provide that? And we generally use capacitor for this reactive power compensation. We generally say like that reactive power not lagging leading reactive
Yes,
power
yes, yes,
compensation.
yes,
It
yes,
means
yes.
that it is providing lagging reactive power. And
Mhm.
if you supply lagging reactive power, that means what? If it is taking leading reactive power. Suppose any element is providing lagging reactive power, that means it is taking leading reactive power. That's why
Yes, sir, of
special
course.
it is like that.
Mhm.
So it just go through the slides and read immediately clear. For first or second time, it will be difficult for anyone. Okay, Jignesh.
Okay, okay.
Okay, thank you all for joining, and we will meet in the next session at the same time on Saturday. Okay, thank you all.
Thank you, sir.